Good morning, guys. Today we're going to go over 4.6 and we're going to look at three new items. The first one is just very theoretical, the fundamental theorem of algebra. The second one is very mathematical, how to write a polynomial of least degree when we're given the zeros. And the third one might be tricky initially, but it's very, very simple, but it is a mathematical and theoretical concept. So let's begin with the fundamental theorem of algebra. Even though, it's got a very big and long definition, I'm going to sum it up in a single sentence. An equation has as many solutions, either real or imaginary, equal to the degree of the equation. So a polynomial of third degree, a polynomial of third degree has three solutions. They could be three real, two real, and one imaginary, one real, two imaginary, or three imaginary numbers. So again, the number of solutions is given by the degree of the polynomial. And it can be a mix of real or imaginary solutions, and you can also have repeat zeros. Sometimes we're given, something that looks like this. Even though you say the solution is 2, when we're talking about the number of solutions for the fundamental theorem of algebra, each one counts as an individual answer. So repeat answers count as a different answer for the fundamental theorem of algebra. If I were to tell you, please let me know how many solutions this might have, you just say, well, it has 5 possible solutions. Now, I don't know yet if these possible solutions are real or imaginary, but that's what we're going to try to figure out today. And we're also going to use many of the tools you've used before in order to find the solutions. Again, we can graph, we can factor, we can use synthetic division. Yesterday, with we learned how to find the possible solutions. Now, using all these tools and the Descartes Rule of signs, we can actually pinpoint where some of these solutions might be to make our job easier. So again, the first point, the fundamental theorem of algebra, just tells you how many possible zeros you might have to look for. If you're given a polynomial like this, and you've actually already found 2 real zeros, you can stop. There are no other zeros. Okay, those 2 are the actual 2 solutions. If you find one, but can't find the other via all these methods we already know, just don't freak out. It might be that one real solution and one imaginary solution. You'll see later how we can find them out. Why not? That takes care of the fundamental theorem of algebra. Now, we're going to write a polynomial of least degree with a lead coefficient of 1 when we're provided some zeros. An example that we have, for example, if you look at the exercises and you look at number, let me do one myself because, again, I was about to do the homework. Let's say they tell me that the zeros of a certain polynomial are these numbers, and I'm also told that the lead coefficient is 1, and I am asked to write the polynomial of least degree that includes these zeros. It is quite simple. All we have to know is that if these are the let's change this one just to make it a little bit better. If these are the zeros, what would the factors be? Now I'm working backwards. I know my zeros. I'm trying to find a possible polynomial. I know my zeros. These are my zeros. So what are my factors? I switch the sign. If 2 is a 0, I know that x minus 2 must be one of my factors. Because when I plug the 2 into my factor, I get a 0. That's what makes the 2 a 0. If negative 3 is a 0, I know that my factor has to be positive 3. When I plug negative 3 into my factor, I get 0. That makes negative 3 a 0. So again, remember, we switch the signs. the zeros and the factors are of opposite sign. And the last one you should know already is x minus 4. So given these zeros, I was able to obtain these factors. Now, how do I find my polynomial? It's quite simple. Let's look at a basic number. If we look at the factors of, say, 24, we have 1 times 24, 2 times 12, 3 times 8, 4 times 6. These are all my factors. So how do I end up with the original number? By multiplying. When you multiply the factors, you get the original number. So what we're going to do is we're going to multiply, doesn't matter the order, because it's multiplication. We're going to multiply these 3 factors. Now remember, some students freak out. Prof, I know how to multiply 2, but I don't know how to multiply 3. Relax. We multiply 1 times the second, and then the answer is multiplied by the third. The order doesn't matter. So let's try the first 2. X minus 2 times x plus 3. Since these are binomials, you can do FOIL, but remember, just don't do FOIL. Do top to bottom multiplication. It's always going to help you. So, positive 3 times negative 2 is negative 6. Positive 3 times x is 3x. X times negative 2. Remember, we write the degrees that are alike on top of each other. And x times x is x squared. Now I add my answer. I'm left with x squared plus x minus 6. So that is the result of multiplying my first 2 polynomials. Now let's multiply the answer of the product of these 2 times the last binomial. So I have x squared plus x minus 6. And under that one, I have x minus 4. Again, here you would not be able to do FOIL. That's why I do not recommend you do FOIL. Top to bottom, always. Negative 4 times negative 6 is positive 24. Negative 4 times x is negative 4x. Negative 4 times x squared is negative 4x squared. I'm done with my negative 4. Now let's work with my x. X times negative 6 is negative 6x under my like term. X times x is x squared under my like term. X times x squared is x cubed. I put that number way at the back. Now when I add everything, I'm left with x cubed minus 3x squared minus 10x plus 24. That right there is the answer of the question. Give me the polynomial of least degree and leading coefficient 1 that has these zeros. Now, why do they state of least degree? Simple. You can actually increase the values of x. You can do a whole bunch of different things to modify the polynomial and still have these zeros. So that's why they explicitly state of least degree and also lead coefficient of 1. Again, given the zeros, you create your factors. Once you have your factors, you multiply. The answer is the polynomial you're looking for. Okay, for the Star Wars fan, this is the polynomial you are looking for. That's it for writing a polynomial. Now let's go back and look at the last one, Descartes Rule of Signs. Now this again might be slightly tricky in the beginning, but you'll see that as you practice, it is quite simple. Now I'm going to start with a very, very small polynomial, then we're going to work our way up. And first of all, what is Descartes' rule used for? Well, Descartes' rule tells you of all the possible solutions, how many might be positive and how many might be negative. So if Descartes' rule of sign tells you that there are no negative possible solutions, then with synthetic division, you would just not do those. You just focus on the positive solutions. So it really helps you narrow down your work when you're working with very big polynomials with multiple solutions. So let's look at one example. Let's look at example 2 that is in the book. And again, I consider this a small polynomial. X to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. Now, in the Descartes rule of signs, we're going to count how many times the signs change from one term to the other within the polynomial. So let's begin. This is a positive number. And after this number, I have another positive number. So no sign change happened there. But from this positive number, now I go to a negative number. So a sign change did occur. And I put a small arrow there to remind me. From this negative number, I go down to another negative number. And from this negative number, I go down to another negative number. So only one sign change happened in this case. Okay. Let me just confirm. Okay, yeah, that's pretty much it for the sign changes. Now, let's go over another example. That was the first example of sign changes. Let's go down to example 4 now, the one that's listed in the book. I have x to the power 6 minus 2x to the 5 plus 3x to the 4 minus 10x cubed minus 6x squared minus 8x minus 8. Now this is more or less what you can expect for in a test. A lot of terms, a lot of sign changes. So let's begin with the sign changes. Note, I just copied my polynomial and I'm checking for sign changes. So let's look at the first. Positive number to a negative number, a sign change happened there. From a negative number to a positive number, a second sign change there. From a positive to a negative, a third sign change happened there. And then negative to negative, no sign change. Negative to negative, no sign change. Negative to negative, no sign change. So I had 3 sign changes when f of x, when my x is positive. Note, I said I did not change my polynomial, and that's important for a reason. When you don't change your polynomial, when you don't modify your polynomial, the number of sign changes tells you how many possible positive solutions you might have. A maximum of 3. There is no way this polynomial will have 4 positive solutions. So when you list all your solutions and you start doing synthetic division, once you find 3 positive zeros, you don't have to input any more positive numbers because they do not exist. 3 or less. Now, that's important. And this is, you have to be very clear. I'm not saying it has 3 positive solutions. It has 3 or less. Now that or less is very important because you're always going to subtract 2 from this number. So it's either going to have 3 positive solutions or 1 positive solution because it's 3 minus 2. There is no way this polynomial will have 2 positive zeros or solutions. It's either going to have 3 or it's going to have 1. There can be no other answer. Okay. Now, again, some students sometimes don't understand. Prof, I don't understand, minus 2. Let's say, for example, that a polynomial has 8 sign changes when I do not modify my x. That means I'm going to have either 8 positive zeros or 6 positive zeros or 4 or 2 or no positive zeros. That's why you subtract 2 every time. If you want to know why, we can set up a voice call, or I can just let you know when we get back into school. But that's pretty much the basic rule, minus 2. Now notice, we've only been finding the positive zeros. When you leave your polynomial as is, it tells you how many positive zeros you might have. Now, how do I find the negative zeros? It's almost the exact same process, only one very small change. Only one very small change. You copy your polynomial exactly as is, only now, instead of using a positive x, we use a negative x. Positive x tells me how many positive solutions I have. That's one way to remember it. Remember, I'm talking about x, not coefficients. I did not change anything. That means your x's are positive. I didn't change anything. X's are positive. Now, instead of x, I'm going to plug in negative x. I always recommend you use parentheses. So instead of x to the 6, I have negative x to the 6. Then I have negative 2, parentheses, negative x to the 5th power, plus 3, parentheses, negative x to the 4, minus 10, parentheses, negative x cubed, minus 6, parentheses, negative x squared, minus 8, parentheses, negative x, minus 8. I'm sorry for the numbers at the end. I'm going to write it in a lot clearer fashion right now. Now, how does this change the polynomial? Easy. Now, when we follow PEMDAS, you know you have to do the exponent first and then multiply. So let's see how this changes the situation. A negative number elevated to a positive degree, you'll end up with a positive answer. Because it's negative x times 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 negative x. I'm going to end up with positive x cubed. Now let's follow PEMDAS properly. A negative number to an odd degree gives me a negative solution. And a negative solution, or a negative x, times a negative number turns this to positive 2x5. Here I have a negative x elevated to an even degree turns positive times positive plus 3x4. I have a negative x to an odd degree. It stays negative times negative turns positive. That's a 3. A negative to an odd, a negative to an even degree turns positive times negative. Positive times negative is negative. That's a 2. Negative times negative is positive. Minus 8. Note, when you change the x from a positive x to a negative x, all that changes is the signs. Notice the numbers stay the same. Notice that the degrees stay the same. The only thing that changes is, in some cases, the signs change. Not always. My x stayed the same, but now my 2 changed. My 3 stayed the same, my 10 changed. My 6 stayed the same, my 8 changed, and my negative 8 stayed the same. So after you change the signs, you're going to do the exact same process and see how many times the signs change from one term to another. So positive to positive, no change. Positive to positive, no change. Positive to positive, no change. Positive to negative, I do have one sign change there. Negative to positive, I do have one sign change there. Positive to negative, I do have one sign change there. So a total of 3 sign changes. So when my x is negative, I have a total of 3 sign changes. What does this tell me? That there are up to 3 negative zeros or solutions. It's the exact same thing. So up to 3 negative solutions. And the same rule applies of subtracting 2. So it's either going to have 3 negative solutions or one negative solution. It's impossible for it to have two negative solutions. Let's say you're doing synthetic division and you find two negative solutions. Go ahead and look for the third negative solution because it's going to be there. There is no way for it to have two. It's either going to have one or three. Now, let's do a table. I'm going to explain the table that is under example 4 in the book. Let's look at our different scenarios. Okay, let's see. Let's put positive real, negative real, imaginary, and total. Now, based on the fundamental theorem of algebra that we saw in the beginning of today's class, since the polynomial was of 6th degree, I know I have to have 6 zeros every single time. You get that right from the beginning just looking at the degree of the polynomial. 6 zeros. Now let's look at every single case. Let's assume I have 3 positive real zeros. And I also have 3 negative real zeros. Again, there is no way to tell how many you're going to get just by looking at the polynomial. You actually have to do synthetic division and factoring and graphing and a whole bunch of ways to find the actual zeros. But this just tells you the possible outcomes. I might have 3 positive and 3 negative real. If I have 3 positive and 3 negative and I have a total of 6, that means I cannot have any imaginary solutions. Now let's see if I have different cases. Let's say the second case, I have 3 positive, but 3 minus 2 negative real zeros, or 1 negative real zero. In total, I have 4 real solutions. That means I would have to have 2 imaginary in order to end up with my 6 zeros. Now let's look at a second case. I have 1 real, 3 minus 2, and 1 negative, 3 minus 2 solutions. If I have 1 positive real and 1 negative real, that means I must have 4 imaginary to end up with 6 solutions. And the last case, I have 1 positive real and 3 negative solutions. 1 positive and 3 negative. That means I'm missing 2 imaginaries in order to end up with a total of 6. There can be no other outcome. So say you're working with synthetic division and you find 2 real zeros, positive, 2 positive real zeros. That means you have to look for a third because there is no way you're going to end up with 2 positive real numbers. Are we clear? Now, you might have to watch the video a couple of times. That's fine. Descartes Rule of sign is initially kind of difficult to wrap your head around, but once you get it, it's incredibly easy. Count the sign changes. That tells you how many positive possible real solutions you have. Change your x, do PEMDAS to see what you end up with. Count the sign changes again. That tells you how many possible negative zeros you have. And remember, those possible numbers are either that number or 2 less, or 2 less, or 2 less. Once you know your possibilities, then you can start looking for the actual zeros. You do synthetic division, you do factoring. You will have to graph to see more or less where you end up at. I'm going to give you a couple of tricks later on to help you, but that's it for today's class. Now, for homework, please do 21 and 22, which is finding the polynomial given the zeros, which is, we did earlier today, and also do 33, 38, and 39. And pretty much that's just determining the possible zeros. You do not have to find them yet. But for 33, 38, and 39, I want you to do this table. You're going to show me Descartes' rule of sign, how many possible positive zeros, how many possible negative zeros, and then you're going to build this small table. Again, before you ask questions, I recommend, if you have questions, watch the video 1, 2, or maybe 3 times. If after 3 times you still don't get it, then please let me know. Otherwise, go ahead and upload your attendance, and after that, homework. And remember, make sure you upload your homework. Don't just say, oh, well, I send it. No, that doesn't work that way. If you order a pizza, if you order a pizza and the pizza doesn't arrive at your home, and you call the pizza place the other day and they say, oh, well, we sent it. It just landed in the neighbor's house, but we did send the pizza. Doesn't work that way. Real life doesn't work that way. Make sure you send your work, okay? And make sure you send it at the proper place, or you lose points. Many students have lost points already because you can't follow these very, very simple rules. And note, I am giving you a very small portion of classes, and I'm telling you about 95% of the students have done an excellent job. But that other 5% better catch up, or we're going to have problems. Have a great day, and I expect to see your questions. Take care.